So these equations look pretty simple. We've analyzed the forces on our object. These are the forces on the box. And the forces on the box are the weight, the friction, and the normal force. That's the effect of the ramp itself. We need to use geometry to calculate these two components. So I've said in a past video, and maybe that should be reviewed, is everyone needs to be able to recognize that whatever angle that is the equivalent angle. The explanation for that is in an earlier video for a different question. I'm going to assume that you know that. I also have described this a number of times, that people are going to need to be able to take any vector that's at an angle to their coordinate system and be able to break it up into the portion that is purely in one dimension and the portion that is purely in the other dimension. All right, now we're down to, we've gone through the physics, and now we're down to a geometry problem. We need to solve these equations. This is algebra and geometry. By geometry, the weight parallel, and this is just a bullet, I'm just going to, the weight parallel is equal to, well, it's opposite of the angle, and that's the hypotenuse. I could use the equation sine of alpha is equal to opposite over hypotenuse, where the opposite side is equal to the parallel weight, and the hypotenuse is equal to the weight itself. Remember, weight is equal to mg. You know m, you know g, you can calculate the weight. And I can similarly use cos alpha, adjacent over hypotenuse, to come up with an expression to calculate this perpendicular weight. So now I know, just now solve for the weight parallel, solve for the weight perpendicular, you can put them in there. And that gives us two expressions for the angle alpha. How can you solve that? Let's see, that's two expressions, what's unknown? The friction is unknown, and the n is unknown. But hold on, what's friction? Let's not forget, we have this equation for friction. So what I'm going to do now is we have two equations, A and B, and we want to know alpha. Let's solve for alpha. I'm going to substitute in everything I know for equations A and B. So here's equation A, here's equation B. Equation A says 0 is equal to the friction force. The friction force is this mu times n minus the parallel weight. The parallel weight can be, you can multiply left and right here by the weight, and you can say the weight sine alpha is equal to the parallel weight. And here you can multiply left and right by weight, and you can say weight cos alpha is equal to the perpendicular weight. Now, I know everybody's waiting, no, many people will be waiting just for the answer at the end. But you need to be, try to be following, paying attention, so that you can reproduce similar arguments to this in future homework problems and on tests. So it's not just a matter of, you could fast forward to the end of the video maybe, but it's not to your advantage. You will answer a low value homework question easily, but you won't be able to answer a high stakes final or midterm question. So I'm back to wondering what my weight parallel is. It's equal to the weight sine alpha. And my second equation says 0 is equal to n. I don't know n. And minus the perpendicular weight, which is the weight cos alpha. I know my weight, it's mg. I don't know this n, and I don't know alpha. So why don't I eliminate n and just solve for alpha? So I'm going to do, if I bring this to the left side by adding w sine x to both sides, and I divide by mu s, I'll have w sine alpha over mu, the static friction coefficient, is equal to n. And if I take that and substitute that into this equation, two equations, two unknowns, eliminate one of the variables. This is a standard maneuver from algebra. This second equation says 0 is equal to w sine alpha mu s minus w cos alpha. Well, how can we solve for alpha? We have a sine and a cos. Everyone is going to need to know that tan alpha is equal to sine alpha over cos alpha. That is a standard identity from trigonometry, and we're going to try to combine our sine and cos. So if we can come up with this ratio, we can bring these two alphas together and solve for them. So I'm going to take cos theta over here. So I'm going to say, or cos alpha. And now I'm going to divide by cos alpha. It's getting close. This implies w. Oh, and look. I also have a weight on both sides. I can cross that out. Actually, I'm in jeopardy of doing too many steps at once and confusing everybody more than they are. So I'm going to not worry about my weights yet. I'm just going to bring that over. Say that I have weight cos alpha is equal to weight sine alpha over mu. And then I'm going to divide by cos alpha and have weight on one side equals to weight over mu on the other, sine alpha over cos alpha. I've already said this sine alpha over cos alpha is equal to tan alpha. Notice you have weights on both sides. Those cancel. Multiply left and right, so that's a 1. Multiply left and right by mu s. And we'll have mu s is equal to